Today we're going to be looking at how to find vertical asymptotes. The definition of a vertical asymptote is a rational function of the form r of x equals p of x over q of x. In its lowest terms, we'll have a vertical asymptote of x equals r, where r is a real zero of the denominator. And in our representation above, our denominator is q of x. So let's work through a few examples. So the first example we have on top is f of x equals x plus 4 over x minus 1. Now this is a rational function. It is a fraction, and it is in its lowest terms already. Can you have a zero in the denominator of a fraction? No. So if I set the denominator of the above fraction equal to 0 and solve this, this will tell me the values that x cannot be, which in turn tells me the vertical asymptotes. So we're going to take our denominator, which is x minus 1, and we're going to set it equal to 0, and we're going to solve. So we want to get x by itself. We're going to add 1 to both sides, and we're going to get x equals 1. This is the values of x that x cannot be. X cannot be 1. So we're going to have a vertical line at 1, a vertical asymptote at 1. X equals 1. So this is our vertical asymptote. Oops, I covered up. So this is our vertical asymptote. And now let's look at the second example. G of x equals x squared minus 9 over x squared plus 4x minus 21. This is a rational function, but it could possibly not be in its lowest terms. So first we need to factor the numerator and denominator of g of x to determine if it is in its lowest terms. So let's factor the numerator first. The numerator is a difference of squares, so we're going to have our set of parentheses, and we're going to have x and an x, because the square root of x squared is x. And then the square root of 9 is 3, so we're going to have 3 and 3, and one's going to be positive and one's going to be negative because of our difference of squares. And now let's factor the bottom, and we're going to have our parentheses, and our first term is going to be x for both. We don't have any coefficients on x squared. And then so we need two numbers that multiply to be negative 21 but add to be 4. And this turns out to be 7 and 3, and it's going to be a positive 7 and a negative 3 to make 4 and negative 21. Looky here, we have x minus 3 and x minus 3 on top and bottom, so they cancel out, leaving us with x plus 3 over x plus 7. So the polynomial was not in lowest terms. Now that we have g of x in lowest terms, we can find the vertical asymptotes. We can do this by setting the denominator, which we have as x plus 7, equal to 0. So we're going to have x plus 7 equals 0. And now we're going to solve for x. So we're going to subtract 7 from both sides, and we're going to get x equals negative 7. And this is our vertical asymptote. Our vertical line is x equals negative 7, because x cannot be negative 7 because it would make a 0 in the denominator. In the next video, we will talk about horizontal asymptotes.